Okay, so let's get started. We're going to be taking a look at setting up and working with our gear cut feature. Once again, this tutorial, we're going to be focusing on setting it up for an H-pattern dog box transmission with a strain gauge, but implementing some of the advanced control strategies and features we have in this specific gear cut control routine. So this is going to be expanding upon what we've learned about in our previous tutorial, taking a look at the H-pattern dog box strain gauge control. That was more of a basic tutorial. That was assuming you're a cable driven throttle. Now I'm going to be introducing drive-by-wire for the control, where we can have a throttle blipping effect when we're making a downshift. So we're going to be programming that into our control routine. We also have the ability to turn on some advanced programming so that we can get a RPM calculation when we make a gear change, either an up or a downshift. So the link knows what the optimal amount of engine speed should be versus your actual engine speed. It can apply the percentage of cut and the torque reduction as a function of this calculation, where the link's going to know what the optimal RPM should be so that the dogs can mesh and align and you have the greatest possible gear shift exchange, so the smoothest gear shift exchange, whether you're making the upshift or downshift. This will make a little bit more sense as we dig into the tutorial. This is a feature that I definitely recommend to use whenever possible because it does simplify the control routine. It actually makes it more accurate for your gear cut control. Let's jump in here and take a look. I've restructured a few things here in our software and the page layouts. I want to explain that a little bit different than the last two tutorials, taking a look at our gear cut feature using the clutch switch and then the previous H-pattern dog box strain gauge tutorial. So let's go here to layout. If we jump down in here, we're going to find that we have a couple new page layouts, and we're going to be using these in the future tutorials talking about our gear cut. First thing I want to point out here is what we're going to be working with is the H-pattern clutch shift option. That's going to be replacing what I talked about in the previous tutorials as gear cut. So I needed to go and have special pages for sequential transmission with a strain gauge, or sequential transmission with a gear barrel position, or a sequential transmission for paddle shift, because it's quite different in the control strategy and routine here based on what type of control you're working with. So I wanted to have a dedicated page here for H-pattern clutch shift. That's what we're going to be working with in this tutorial. We'll be digging into these other tutorials, the other pages here and other tutorials coming up here very shortly in the training course. In fact, the next few tutorials. All right, let's jump in here to H-pattern clutch shift and let's take a look at a few things. We're going to do a quick recap of the settings and just how all of this works. Then we'll dig into implementing first the throttle blipping feature and then introducing some of the advanced calculations that the link is capable of to improve our control strategy with this H-pattern strain gauge type of combination. So let's go through our gear shift control, just run through some of our settings here so we just get a general idea what's going on, and then talk about some of our control tables. And then we'll talk about how this can differ based on implementing our advanced strategies. Okay, so under our gear shift control, in this particular tutorial, we're taking a look at the start shift mode as gear lever force H-pattern. This is specific to an H-pattern dog box transmission with a strain gauge. So pretty simple there. I do want to point out, if you have gear lever force H-pattern, you obviously have to have an H-pattern dog box transmission, and you also have to have a strain gauge either bonded to the shift knob or the shift lever, and we need to set that up here under our gear lever force. Now, we talked about how to do that in the last tutorial. I'm not going to get into those specific details here. Again, that's already accounted for in my configuration here. And then the shift force that we specify here is our threshold that we have to actually exceed, whether it's a positive or negative shift force that we're finding. Doesn't matter. My strain gauge is going to be a bidirectional strain gauge, meaning it can either output a positive or a negative value for the shift force if I'm making it up or a downshift in the direction. It makes it bidirectional. So we set all that up here, and the threshold that I've programmed is 30 newtons of force for it to count as a gear shift, or to the control to start, I should say, not necessarily a gear shift, but where we want our cut routine to start. So it has to exceed this newtons of force. Okay, so if we go back here to the top, let's go under our end shift mode. This is currently set to time. When we're talking about this control strategy, we typically set this to time. There are some other options here. Digital input that's used for a clutch switch and gear barrel position. This is a sequential transmission type of feature. Typically dog boxes, H pattern dog boxes specifically won't have a gear barrel position, essentially giving you a gear position reading. So we're going to assume that we're just doing this all based on time, and we're going to leave it on time. Cut mode should be set to ignition cut in most cases. Ignition cut is a more effective way of controlling your torque when you're making your gear shift. So the whole purpose of working in this control routine is that we're controlling the engine's torque output so that the dogs don't crash and they can align better, and we can ramp the power back in after we make the gear exchange at full throttle. So ignition cut is what I typically choose unless I have an engine that is sensitive to ignition cut, and then in that case I would use fuel cut, but ignition cut is what we're going to use for our cut mode. Start shift validation time is pretty simple. What this is going to do is take a look at whatever the shift force is going to be. I mean, we have to go above or below that, so either a positive or negative 30 newtons of shift force for it to count it as a shift. But what we'll find here is that it's going to wait 10 milliseconds after it starts to see the shift force exceed our threshold here before it allows the gear cut to actually happen. So this is going to act as a kind of a buffer so that we can't, let's say we're hands on the shifter and we're accidentally kind of jarring the shifter a little bit. This is going to give us a little bit of a buffer so it doesn't count any immediate spikes or tiny little fluctuations in the gear lever force. 10-20 milliseconds is a good value here to kind of get things going. I'll leave it at 10 for right now. Upshift TPS, low lockout, and low lockout source. This is going to relate to whether it's counting an upshift request. We have to be above this percentage of throttle movement. Now, the source is important. I'm going to be drive-by-wire in this example because we're using a throttle blipping feature. The last tutorial I presented all of this if you were a cable-driven throttle body. So because I'm drive-by-wire, I'll choose Excel pedal position sensor. That's what we actually interface and put our foot on in the vehicle to translate the throttle blade opening drive-by-wire specific. So if you're cable driven, then you'll be using TPS, but drive-by-wire APS is what we want to choose. So we have to be careful of this threshold amount. What this is saying here is that below this threshold, we're not going to, even if we see a shift force increase here and it elapses that time, it's not going to do anything with the gear cut routine. As soon as we're above that throttle angle, then it's going to, or not necessarily throttle angle, but in this case, Excel pedal movement, moving our throttle input. If it's above that, then if it sees that shift force exceed, then it'll go through the gear cut routine through our tables here. When we're talking about drag racing, I would recommend to set this pretty high, something like 70-80%. That way you have to be at full throttle to make that gear exchange happen. And when we're drag racing, we're essentially at full throttle to use this type of gear cut feature. If we're going to be on a road course car, autocross, road racing, we're definitely not going to be at full throttle all the time. So we have to lower down our TPS APS threshold here to a reasonable value. Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.